Hey everyone. As a multi-cloud architect, I've seen so many projects get completely tangled up by this invisible force. It's something that quietly dictates where your applications can run, how your user experience feels, and honestly, it can make or break your entire multi-cloud strategy. Today, we're going to put a name to that force: data gravity.
It really all boils down to this one simple question, doesn't it? We're sold this dream of a flexible, agile cloud. So why does it so often feel like our data is just stuck in concrete? Why can't we just pick up a database from one cloud provider and drop it into another? Well, the answer is that your data, a lot like a planet, has its own gravity, this invisible pull holding it and everything that depends on it right where it is.
So let's call this what it is: the pull of data. We're going to dive right into this concept of data gravity and see exactly how it shapes the entire cloud universe we work in.
So what is data gravity, really? Think about it like this. As your data set gets bigger and bigger, it starts to exert a gravitational pull. Pretty soon, more applications and more services are drawn to it because they need to be close to the data to perform well. And over time, this makes moving the data itself an incredibly difficult and expensive task. The data literally becomes the center of mass, and everything else just falls into its orbit.
And this has very, very real consequences for any stateful workload. We're talking databases, user profiles, things like that. The more data you have, the more inertia it builds up. Your biggest, most critical data sets don't just support your architecture, they pretty much become its anchor. Okay, so if data gravity is the force, what are its laws of physics? In this multi-cloud universe, it all comes down to two inescapable principles: latency and consistency. And trust me, understanding how these two things interact is the absolute key to building any system that spans multiple regions or multiple clouds.
Let's break these two down. Latency, that's basically a speed problem. It's the physical time it takes for data to travel from point A to point B, and it's limited by the actual speed of light. Consistency, on the other hand, that's an accuracy problem. It's all about the architectural guarantee that all copies of your data, everywhere, are identical at any given moment.
All right, theory is great, but let's make this real. Let's walk through a super common multi-cloud scenario: replicating a database from AWS in the United States over to Azure in Europe, all to give our European users a better experience.
So here's our setup. Our main database, the primary, is sitting in an AWS data center on the US East Coast. To speed things up for our folks in Europe, we create a read replica over in an Azure data center in, say, Western Europe. Now, a user in Paris makes a request to see the latest information. But it's not instant. They feel a little lag. What's going on here?
The delay is caused by this number: 100 milliseconds. That's roughly the round-trip time it takes for a packet of light to travel through a fiber optic cable from the US East Coast to Western Europe and all the way back again. This is the speed limit of the internet, and it's imposed by geography and, well, the laws of physics. And this leads to what is probably the most fundamental truth for any cloud architect. You simply cannot write a clever piece of code or buy a faster server to get around the speed of light. Over these kinds of distances, latency is a physical constraint. It's a fact of life, and you have to accept it and design your entire system around it.
So, if we can't break the laws of physics, what on earth can we do? Well, this is where the real work of an architect begins. We're forced to make conscious, strategic decisions. We have to choose our trade-offs.
You're basically left with three main paths. You can choose to prioritize consistency. This means every single transaction has to be confirmed by the primary database before it's done. It's perfectly accurate, but it feels slow for users far away. It's ideal for something like a bank transaction. Or you can prioritize low latency. Here, the local database responds instantly, and the primary just catches up later. This feels super fast, but you risk users seeing stale data, which is totally fine for something like a social media feed. And finally, there's the balanced approach, which offers flexibility but introduces a ton of complexity. The key here is that there's no single best answer, only the right answer for your application.
So, to wrap this all up, what are the crucial points to remember? First, data has gravity. Always, always design with your largest data set at the center of your thinking. Second, latency is a law of physics, not some bug you can just fix. You have to design for it. Third, consistency is an architectural choice, and every choice has consequence for your users. And finally, remember there is no magic solution. Every multi-cloud data strategy is just a series of well-reasoned trade-offs.
So I'll just leave you with this one question to take back to your own projects. As you're architecting your next system, look at your core data and ask yourself,
Is this data a massive planet that everything else has to orbit? Or is it more like a smaller moon, something that can be moved and replicated a bit more freely? Your answer to that question is going to define everything that follows. Thanks for watching.